So this is the Intermittent Drainage Interview production by Bronson, Jayden, me, Caeden, and Tharuni, who unfortunately isn't here. So the idea for IDEP is we wanted to put water turbines in drainage systems such as storm drains, sewers, anywhere where a lot of rain would go through, but also like say in like wastewater management facilities, like as they're cleaning the water, that could also produce a little bit of power too.
So for our overall prototype, in terms of our model here, it's going to be representing the pipes that would be in sewage systems or anything where water would be flowing through. And we have our propeller here that would be moved by water movement, and that then generates electricity through our water turbine or our electric motor, and that lights up our light bulb here, which is essentially using our energy. Since we didn't have a battery to actually store charge, and then all of this system is monitored by our Raspberry Pi, and the Raspberry Pi collects data on the system. So in terms of volts, wattage generated, current, resistance, as well as the RPM of the motor itself.
I'm going to click the video.
That's fine.
For implementation, it would be prime to put it where there's more rain. So we were thinking initially to put it in the northwest portion of the country, just to ensure that it's getting accurate data from it. For these purposes, we would want governments to implement where it's going, whether it be in small towns or large cities, depending on which one they think would fit best. Excess energy produced whenever it's stagnant or there's less rainfall would be stored in water treatment plants, almost as acting as a battery. And then on a household scale, if we were to go that small, you can put it on the inlet side for your water. And then with it going on the inlet side, your profit margins would increase with more efficient water turbines, which also opens the market for smaller or even larger turbines, depending on which scale you want to go. Which currently the price range for water turbines on the smaller side, they're about $1,000, and then on the larger side, they're about $30,000. Which that sounds like a large price market, but if you have a large number of smaller turbines, your number is going to be slightly different than if you had a lot of large turbines. And then if you've got corporations selling energy to the city, or if you have the city selling energy back to personal homes, that would also change your profit margins. And then implementation timeline would be about 6 to 12 months if they have incentive, but if they don't have incentive, it would probably be closer to the 12 to 18 month mark.
In terms of system management, so as a Raspberry Pi would be acting as sort of a computer that would monitor the system. So implementing this in like a large scale, we'd have like an actual computer to be able to monitor data, as well as maybe adding more sensors like a temperature probe and other things that allow you to sort of collect data and create models of what's predicted for that electricity generated, as well as sort of help prepare for any maintenance that might be needed with the whole system itself. And some of the issues that could happen when deploying this could be that sort of you have blockage within the system, within the sewer, and that could sort of prevent or create floods onto the street, which already occurs typically. And this is something that could be sort of prevented or taken care of by running current through the motor itself in order to spin the propeller and sort of push the debris out of the way. And also, over time, it's a bunch of moving parts, so there is going to be wear and tear, and you are going to be having to do conduct maintenance on it regularly, and overall, if the wheel itself breaks, that could also then prevent a bunch of flow of water throughout the system, which could lead to burst pipes and things of that nature.
For metrics, the expansion of the IDEP system would initially require about 10 megawatts for the first year, which sounds like a lot, but in perspective, whenever you have a system, then each turbine is contributing to the production of the energy. And then with the system being in more of the wet climate, it'll essentially help it get the optimal amount of energy produced, and then with that data you can use it to predict how it's going to work in other situations, maybe by reducing the input numbers.
Well, it was a video. That was
I can't show the whole thing, but I used Minecraft to show a 3D model of the application in the city setting. So just the water going down, and this is a very simple way of showing the propeller spinning the water, and then going down into where the water would usually go. And like, we could have more of them in the series. And
thank you for coming to our TED Talk. We do take Bitcoin donations, and you guys like send to that wallet address.
You want to turn it so they can see the light? That might be helpful. Okay. Aw, bigger mess than anticipated.
I saw the light.
But we didn't have light. That was one of our issues yesterday. It wouldn't always light up. But
Judges are free to ask questions.
okay.
Is the pie doing anything?
Not right now, no.
because
We need to have it plugged up. But if the Pi were on, then there would be magnets on here that, as it spins, an electromagnetic sensor would be, or electric sensor would be, magnetic sensor would be here, and as this rotates, it counts how many times it's rotated, and the Pi will calculate the RPM of the device. We were going to install what's it called, current and voltage sensors, but we learned that those are in analog and not digital, which can't be read by the Pi. So we sort of scrapped that and are just
And we didn't have a
sort
multimeter.
of calculating the voltage based off the rotation of the motor itself.
Thanks for the explanation.
So what size pipe and what kind of flow rate would you think would be optimal?
optimal, with how many different variations there are, you could be looking at anything from a 2-inch pipe that's implemented in other countries, or you could be looking at like a 6-inch pipe, depending on which scale. But flow rate would really, that's hard to kind of determine, because if you're going downhill with certain pipe materials, they tend to have more friction inside of them. We look at flow rates for those. I didn't know. I'm not 100% sure.
Visually, it looks like you want the pipe half full.
That would be prime, because if there's pressure on both ends of the propeller, then it's just sitting there and creating more of a blockage than actually producing energy. So, but then if it is majority of the way full in times of floods, then you could apply power to kind of flush the water out.
Kind of going off that, you chose to use this propeller design. Did you look at like axial propellers at all? So that would be like with the same.
We did, however, we didn't have a model here that we could use for a prototype, and none of us are really skilled in CAD to be able to 3D print in the time that we had yesterday. So this was
That's something I could see. If the pipe was completely full, you could use an axial
Right.
propeller.
Hey Lance, just out of curiosity, are you keeping tabs on the 4 minutes for the Q&A as well?
Next time I will start.
So since the pi is not working, that means like the prediction models and those things are actually not implemented, right?
not on the prototype, just because we couldn't attach the magnets without them interfering with, like, we attempted yesterday, we had a hole where this was inserted, but the propeller was actually hitting it because it was too close to the edge. We couldn't
And
get
our
it
magnets
centered.
were strong enough to
That
reach.
too. So if we had stronger magnets and we were able to put the sensor on the outside, then it would have been functioning. However, with the time frame we had and the materials available, we
Yeah.
cannot.
So do you have something in your mind like to implement the prediction model, like which machine learning models or whatever you would use?
Read.
Oh, sorry. Yeah.
That means 30 seconds?
Oh.
So yeah, so yeah, that's fine.
Implementation models. I don't know. That was more you guys.
What?
I just built it.
What was the question again?
So the question is like that if you have anything in your mind, like which prediction models you will use, like the machine learning model you will use for predicting the upcoming disaster or some, and then adjust to the propeller rotations or something.
No, but in terms of sort of the rate of the RPM.
Stop.
Yeah, that's a nice prediction. Thank you.
Got it.
I like the breadth of that idea.